Sumit Patel. Today I am presenting SimMatch semi-supervised learning with similarity matching. Nowadays, in the community of computer vision and machine learning researchers, learning with few labeled data has been a challenging task. So for that reason, this study provides the SimMatch framework, a new semi-supervised learning method that concurrently consider instance and semantic similarity. In SimMatch, the same class prediction and the same similarity relationship to other instances should be respected across all of the multiple enhanced view of the same instance. Utilize the instance level ground truth labels and the close gap between the semantic and instance similarities. Author created a label memory buffer, the unfolding and the aggregation operation which enable these two similarities to be isomorphically altered with one another, and that was the final proposal. After that, SimMatch achieves 67.2% and the 74.4% top 1 accuracy with 1% and the 10% labeled instances on ImageNet with 4000 epochs of training respectively. SimMatch framework and its significance. In this following figure, we can see that for each category, the fully connected layer vector can be seen as a semantic representative or a class center. However, the semantic class data is not always accurate because of the small number of labeled data examples. After that, SimMatch adopts a label memory buffer and takes into the account level and the semantic level information simultaneously in order to fully utilize the ground truth label on instance. Label data is directly involved in a joint feature learning with pseudo labeling with replacement in two stages, pre-training and the fine-tuning. In this article, author introduced SimMatch, a brand new semi-supervised learning system that is depicted in a various figures. In SimMatch, we propose to match the similarity relationship of both semantic and the instance level concurrently for various augmentations by bridges of these both. The existing techniques for the semi-supervised learning in deep neural network. There are three approaches: mix match, remix match and the fix match. In the mix match uses the mix up method for improve the pseudo label by adopting a sharp average prediction of many substantially augmented view as a pseudo label. After that, in the remix match, which provide a distribution alignment method that promotes the pseudo label distribution to resemble the margin distribution of the ground truth class label. And the last one is the fixed match. In this, unlabeled photos are only kept if the model generates a high confidence pseudo. Here, this figure shows the label generation process. In this, pseudo label and the instance pseudo label using the weak augmented view. Author will compute the semantic and the instance similarity using the class center and the label embedding. Then after combining these two similarity using unfolding aggregation technique to get a pseudo. After that, this is the formula for the semi-supervised learning. This is the instance similarity matching. On the other side, author can calculate the similarity between the strong augmented view ZS and the ZI as in SIM, and then this formula is written. T here the T is the temperature parameter that controls the sharpness of the distribution. Finally, the consistency regularization can be achieved by minimizing the difference between Q of S and the Q of W. These are the formula. And after that, the overall training objective for the other models will be L overall is L of S plus lambda of U plus L of U. That label propagation's underlying theory. This theory indicates that the output pseudo label will be significantly sharper and produces the high confidence for a particular classes if the semantic and the instance similarity are Here is the implementation details. Author uses a standard SGD optimizer. Top 1 accuracy comparison on cipher 10 and the cipher 100 with varying label set sizes. They had a set initial learning rate 2.03. Is the outcome. The same match perform at it's based on the variety of setting, particularly on cipher 100. Same match performs significantly better with 400 with 40 labels for cipher 10, but only modestly better with 250 and 4000. Here is the training efficiency. Author tests the actual training speed for a fixed match, co-match and the sim match. Compared to fixed match and co-match, sim match is over 17% faster. The weekly enhance U will be sent into the internet network in a fixed match. It uses up more resources due to the additional computation graph. After that, SimMatch only needs one forward pass for EMA network, in contrast to CoMatch, which needs two strongly and weakly augmented. For here are the graphics that the first graph shows that pseudo label accuracy, second one is unlabeled sample exam accuracy, and the third one is the validation accuracy for fixed match and the sim match on 1% and top 10%. Lastly, we can conclude that in this article, I propose a SimMatch, a new semi-supervised learning framework that takes consistency regularization into account on both the semantic level and the instance level. Here author built a label memory buffer. So finally the label can spread between the semantic level and the instance level information and define the unfolding and aggregation method.